And let's solve one more question where we can apply circle theorem rules and start by looking at the shape and think of the first angle that you can find. So as for myself, and I would like you to always read what's given in the question as well, and that which might not be represented on the drawing, such as, for example, this sign and this sign. It's telling you that this triangle is an isosceles. But here, if you look, A, B, C, and D are points on the circumference of a circle, center O. So this is the center, which tells me that AC is the diameter because it's the side that's passing from the circumference to the circumference and passing through the center of the circle. So BD and BC, AC is the diameter, BD is equal to, so they're telling you that BD is equal to BC. Right. So BD is equal to BC and angle BDC is 62. Work out the values of W, X, Y, and Z. Okay, we will start at first by this triangle. BCD, which is an isosceles. Accordingly, if this angle is 62, then these two angles are going to be, okay, let me start with this color here. So we're talking about this angle here. We're talking about this angle and this angle. So we will start step number 1 by saying isosceles CBD. We're going to say that angle BCD is equal to angle BDC, and they're both equal to 180 minus 62 divided by 2. So 180 minus 162 divided by 2, 180, sorry, minus 62. So 180 minus 62 divided by 2. Okay, so it's equal to 59. So this big angle here is 59 degrees and W is 59 degrees. So from here we can say that W is equal to 59 degrees. Okay. What else can we think of? Okay, let me first erase this here. What else can we think of? Okay. I can think of the following. Can you see this circumference angle? ADC. Okay. And this center angle, right? Which is 180. So, in other words, if this angle at the center is 180 degrees, then this angle here is half of it, which is 90 degrees. Or I can think of ADC as an angle that is opposite to the diameter AC, and any angle that is at the circumference and opposite to the diameter, it's always equal to 90. So step number 2, we can think of angle ADC is equal to half of 180 degrees, which is the angle at the center, and it's equal to 90 degrees. Or the reasoning, angle ADC is at the circumference and opposite to the diameter of the circle. Okay. Accordingly, from here, we can find in this step, we can find angle X, which is equal to 90 minus W, which is 59. And accordingly, X will come down to 31 degrees. So this small angle here is 31 degrees. Perfect. Okay. What else can we think of? What else can we think of? Okay. Let me first erase this here. Okay, here and here. Okay. And let me read this for again. A, B, C, D are points on the circumference of a circle. Center O, AC is a diameter. BD is equal to BC, and angle DBC is equal to 62. Okay, I can think of, see, when we read the question multiple times, we might come across something that we know. If you look at circumference angle DAC and some circumference angle DBC, angles at the circumference are equal. So we can say step number 3 here, angle CAD is equal to angle CBD, and they're both equal to 62 degrees. So y is equal to 62 degrees angles at the circumference are equal. So this is equal to 62 degrees. Okay. So at last, the final step will be step number 4. We can go to triangle ADC, where we can find angle ACD. So angle ACD is equal to 180 minus the sum of the other two known angles, which are 62 plus 90. And accordingly, 180 minus 62 plus 90, this will bring it down to 28 degrees. So Z is equal to 28 degrees. Okay. So 62 plus 28 plus 90, 62 plus 28 plus 90 is equal to 180. And then we can answer the questions. So W is equal to 59. And the reason behind it, if you don't want to write sentences, you can just say W is equal to 180 minus 62 divided by 2 in the isosceles, right? Which is equal to 59. This is more than enough, and you will get the 2 marks. Okay. X is equal to 31. Right? Because X is equal to 90 minus W, right? Um, we can say circumference angle facing the diameter is always equal to 90 degrees. Okay. And then Y is equal to 62. Yep. Where did we find Y is equal to 62? 62. Okay. Because we've already explained that up there, because angles at the circumference are equal, right? And you can mention the angles actually. You can say angle CAD is equal to angle CBD. So CAD, if I'm not mistaken, CAD is equal to CBD. Last one is 28. And the reason behind it, you can just write 180 minus 180 minus 62 plus 90 is going to give us the 28. All right, so that's basically it. You always need to keep an open eye to the drawing so that you can spot all the cases that might help you in finding missing angles in circle theorem problems. And don't forget like the old rules that you learned about finding missing angles, such as parallel lines, isosceles, angles in a triangle, or straight line angles, or angles at a point, because they do always help you in solving angle questions. So I would say, and I highly recommend that you watch this record as many times as you need to until you nail the rules of finding angles in circles. Thank you so much for watching, and I will see you in the next record sometime soon. Bye-bye.